Good morning, and thank you for joining me today for our StreamWatch Bacterial Action Team virtual training. Today is July 31st, and we are gearing up for Session C of our summer bacteria sampling program, which is set to begin tomorrow. But first, a little background into what we're going to cover today. We're going to talk about the StreamWatch Bacterial Action Team itself and what the expectations and responsibilities are of its volunteers. Then we will go into harmful algal blooms and cyanobacteria to talk about how we're going to conduct our visual assessments when we're out in the field using a phone app or just basically a link on your phone set up through Survey 123. Then we'll talk about our bacterial sample collection and transport to the Watershed Center. And then we'll talk about how we report that information out and give you kind of a list of what your daily or your weekly routine will look like. But first, providing a little bit of context into how this bacterial program fits into the rest of what we do at the Watershed Institute. Our goal to basically summarize it, is that we're working to protect and restore clean water and natural environments in central New Jersey. And we do this in four major ways. The first is through conservation, through land conservation. So we have about 1,000 acres of land preserved, of old farmland, of new growth forests in Pennington and Hopewell. And we use a lot of that land for our educational programs. So right now we have our summer camp program going strong. Every week we have a couple hundred new kids coming out to get muddy and dirty and hopefully to learn a little bit more about their natural environment and about how water quality is so important for all of us. I like to think of advocacy as the step up from environmental education, where it's basically targeting municipalities and state level officials to teach them about why they should care about watershed health and water quality and try to encourage them to enact stronger regulations to protect it. But really what holds up all of these other three categories, conservation, education, and advocacy, is our science programming. So we have volunteers, we have staff, we have different types of programs throughout the year where we'll go out and we'll test water quality, where we'll install restoration projects and measure their effectiveness. And it's really that data that we're collecting that provides the basis for all of the other work that we do. So science is very much built into the DNA of the Watershed Institute. And a big part of our science team is our StreamWatch program. This is the program through which we engage the help of volunteers like you to work on one of three different monitoring teams. The first monitoring team is our Chemical Action Team, or CATS. They go out for an assigned weekend every month to collect some basic water chemistry parameters, things like pH, dissolved oxygen, nutrients, turbidity. We also have our Biological Action Team. They go out 2 times a year, once in the spring, once in the fall, and they collect macroinvertebrate samples, and they identify them to determine, basically the macroinvertebrate populations will tell us if that stream is healthy or if it's impaired. And they'll also do a habitat assessment along with that to help us with that assessment of basically aquatic health. But the team that we're talking about today is our Bacterial Action Team. And for this team, our volunteers are active just for 15 weeks during the summer months. So for bacteria, we're mainly looking at how bacteria levels impact human health. So during the summer months, this is when people are kayaking and swimming and boating and stand-up paddleboarding and everything and falling into the water. And we want to make sure that if someone were to ingest some of that lake water, that they're not going to get sick, right? That's That's kind of the number one thing that we're looking for when it comes to our bacterial action team. But also new this year, we've added another component to our bacterial team where we are also assessing a different type of bacteria, cyanobacteria. You may have heard this referred to as harmful algal blooms. We're adding this visual assessment to our grab samples for E. coli and total coliform. And this is just another way that we can work to protect human health. And because just as we don't want people ingesting water that's tainted with excessive levels of E. coli, we don't want people jumping into a water body that has toxic cyanobacteria that can cause a number of health issues after that. So you guys, you all are really helping to keep this data flowing during the summer months and allowing us to share this information out with the people who need it. So thank you so much for offering to participate. So just a little about the bacterial sampling schedule. As I mentioned, this will take place every Sunday. So we are currently going into sample session C. So here are the dates, all of the Sundays in August, 1st through the 29th. And the samples should be dropped off at the Watershed Center in Pennington by noon, which means that you should get out there, hit all of your sites. Now it's going to vary for you of how long it will take, maybe an hour, maybe 2 hours, but try to get out early enough so that you can hit all of your spots and get to the Watershed Center by noon. I do have this start time as well. 7 a.m. is the earliest that we can go out and start collecting samples. And that is because when we collect a grab sample, which is basically just a bottle that we fill with our water from the stream or lake, we want to measure the amount of E. coli and total coliform in that lake water. But we don't want to give that bacteria a chance to grow excessively in the bottle. So there is a hold time, we call it, of about 8 hours. When you collect that sample, it has to go on ice to kind of slow that metabolic growth. And then it has to get to the Watershed Center where we need to run it in our lab to test it for E. coli and total coliform within 8 hours. So we're just saying you can get out as early as 7 a.m. and probably as late as 11:30-ish, 11:45-ish, depending on where your site is, to get everything to the Watershed Center by noon. Now, what we need from you, first and foremost, is to keep yourself safe. As I mentioned, you are going to be going out to these sites every single week. Hopefully, in your first visit, you'll be able to check out the site and get comfortable with where you will actually access the water. And probably tomorrow, it will take a little bit longer than it will for subsequent weeks, since you'll just kind of be checking it out, figuring out where to park and all of that good stuff. Number one, if you feel unsafe for any reason, please do not feel like you need to collect a sample. This is not life or death kind of work here. If you see like a harmful algal bloom in the water that's active and bright green, and you really don't want to stick your hand in the water to collect a grab sample, I get it. And you shouldn't do that if you're feeling unsafe. You do have gloves in your kit, so you can feel free to avail yourself of that kind of PPE as you're working. Also, maybe you already have, or maybe you will today, pick up a bacteria sampling kit. This consists of a cooler and bottleware and gloves and a thermometer. And I just ask that at the end of our 5-week session that you return that cooler with all of those materials back to the bacterial cabinet where you picked it up. We're also asking that you really try to get out there every Sunday for your 5-week session. The reason for this is that in New Jersey, rather than look at E. coli values singly and just look at one single value and say, this stream is impaired or it's healthy, whatever, we want to look at it from a wider lens. And in New Jersey, what we do is we look at 5 samples collected within a 30-day period. And we take a geometric mean of all of those samples in order to calculate what that geometric average is. And that helps us to determine if that water body is impaired or not for E. coli. So it's pretty important that we get all of those 5 samples within our 5-week period to make sure that we hit that mark. Of course, I understand that things happen, things come up. Maybe you have a vacation that already is scheduled and you've already spoken to me about that. And that's totally fine. This is just our goal. And hopefully we can attain it, but it's summer, a bunch of Sundays. Sometimes it can get rough. So I already mentioned this. We're aiming to collect our samples between 7 a.m. or after 7 a.m. and to deliver everything to the Watershed Center by noon. And lastly, we just want to make sure that we're adhering to our test procedures, especially for our bacterial sample collection. So as I mentioned, we want to make sure that we're measuring the E. coli from the actual water body itself and not from our hands, right? So I'll go into our procedures for how we're going to collect that sample without like sticking our fingers in the bottle and contaminating the cap, what have you. We want to make sure that we're using sterile sample collection procedures. And it's pretty easy. So I think that we can all accomplish this. So the Bacterial Action Team, in a nutshell, our goal is that we're protecting human and animal health and safety in the water. The way that we're going to go about doing this is measuring the extent of bacterial contamination in our waterways. And there's kind of 2 ways that we'll do that. The first way is that you will do a visual inspection of the water body for toxic cyanobacteria and report those conditions using your phone app, using the Survey 123 app, which we'll go over in just a minute. The second way that we'll do that is you're collecting grab samples or just bottles that you'll fill up with stream or lake water. And you'll bring those back to the Watershed Center where we will enumerate, where we'll test those samples for E. coli and total coliform. So first, we'll go into the cyanobacteria. And here, I just want to pause. If I can't really see your video or the chat or anything, are there any questions so far? And if not, we'll just move on. But if you do have any questions along the way, please feel free to unmute yourself and shout them out or just type them in the chat. I should get a little notification on the screen. Okay, so cyanobacteria, they kind of are, it's getting a bad name now that harmful algal blooms are becoming so much more common here in New Jersey. But cyanobacteria are absolutely an essential bacteria just for our ecosystems to function. They are photosynthesizing bacteria. And just as with anything else, it's too much of that bacteria that can really start to cause problems. Cyanobacteria are not harmful algal blooms, but when cyanobacteria start to produce toxins and release those toxins into the water, that's when we refer to that bloom as a harmful algal bloom. It's a little bit silly because cyanobacteria are not algae, it's bacteria, but we still call it a harmful algal bloom just because it's kind of this colloquial term that everyone kind of agreed to use, which is why it's part of our bacteria assessment team and not something like an algae assessment team. But it's commonly referred to as an algal bloom anyway. So some cyanobacteria produce toxins, but not all cyanobacteria produce toxins. The types of toxins that can be produced are cylindrospermopsin, anatoxin, and microcystin. And these types of toxins can really vary in how they impact human and animal health. But the most common, kind of at the ranges that we will typically see in New Jersey, is that we'll see some skin irritation. Like you could start to see kind of like a flaky red skin, where you really just need to wash your hands and put on lotion and it'll probably improve. But it can get worse than that. If you actually ingest that water, you could have some GI issues. You could develop flu-like symptoms. And kind of at the furthest end of the spectrum here, if toxin levels are very high and you're ingesting a lot of that water, it could lead to organ failure. So the toxins can be pretty significant, the impacts on human health. But we tend to see even greater impacts to dogs, to dog health. If you go out to a lake or to a river with your pup, and they go out, they take a swim, they're kind of drinking in the water and everything. And it can really build up in the dog system. And it's very sad. There can be some very sad outcomes from that. So this is a big reason why in New Jersey, when we do see cyanobacteria, we want to report it as soon as possible. But how do we make a harmful algal bloom in the first place? Well, some of these things are typical to lakes or slower water bodies, things like slow moving water and a lot of sunlight. We're heating up that water. We're kind of allowing these cyanobacteria to kind of form. They usually tend to kind of push against the banks of the lake. And so you can kind of see like this kind of green paint streaks as the wind sweeps it right across right at the banks of the lake. But the way that we're helping harmful algal blooms to continue to expand and grow throughout the state and throughout the country is by adding nutrients, things like nitrogen and phosphorus into the water. And so we're basically feeding these bacteria and allowing them to thrive and continue to grow. Add that to more sunlight now as climate change continues to worsen. We see brighter conditions. We see riparian buffers kind of not really protecting the actual water, not shading the water as much. So we're adding nutrients, we're adding a lot of sunlight, and we're seeing a huge growth of harmful algal blooms in New Jersey. There are a few water bodies that currently have harmful algal blooms that are in our monitoring network. Rosedale Lake in Hopewell, Siva Lake and Sylvia Lake on the TCNJ campus also have a harmful algal bloom. Amwell Lake up in Hopewell as well has a potential harmful algal bloom. And so once we actually see a harmful algal bloom establish itself in one of these water bodies, it is much more likely to recur year after year after year. So this is why earlier this year at Rosedale Lake in Hopewell, we're trying to implement this kind of new strategy to help to reduce the impacts of harmful algal blooms and cyanobacteria. At Rosedale Lake, we just put in floating wetlands at two stretches of the lake. As the water is sort of flowing out of the lake, we're trying to intercept it by having these plant roots basically stick down into the water and suck up those nutrients, basically remove the nitrogen and phosphorus from the water so that cyanobacteria are unable to pick it up and use it to grow. So we just put that in April, I want to say, of this year. And we're hoping that this is a strategy that we can continue to implement in other water bodies in future years to just continue to try to reduce our harmful algal bloom issues. So now I want to show you some pictures of different harmful algal blooms, so different ways that they can present visually. So as you're going around to your water bodies, you know a little bit of what to look for. Now, this link here at the bottom, this is on a laminated card in your sampling kit. So you've got on one side of that card the link to get to your online form for Survey 123. And on the other side of that card, you've got a link to this web address. And this will take you to a series of photos of harmful algal blooms. So you can kind of use your QR code, scan that, or type in the link in your phone while you're in the field and look at these photos for reference as you're looking at the actual water body in front of you to kind of compare and see, is this a suspected harmful algal bloom, or is this just, a regular old lake? So one of the main ways that harmful algal blooms will present is what we call pea soup. And so this kind of looks like thickened green water, like the water is actually dyed green, but you can also see like very small particles in the water as well. So you can kind of like look into it, you can swirl it around and it stays green. There's not like the surface coating on it. Green water, basically, for all of these things indicates that there could be a harmful algal bloom. So it could be pea soup. It could be sort of spread all across the water, turning the whole thing green, or it could present in these green streaks. We call these like paint streaks on the surface of the water. And this is commonly what you'll see where the wind will kind of push those streaks to the edge of the water body, just as they are here. And so, yeah, that's a pretty common way that it presents. That's how it's presenting at Rosedale Lake right now. Also, possibly harmful algal blooms is this green foam. So on the surface of the water, if you're seeing those paint streaks, or if you're seeing actual green foam starting to form on the surface of the water, especially if beneath that green foam you see green water, that's definitely a suspected harmful algal bloom. And then this is kind of another version of that pea soup. You see very small green dots. If you were to zoom in on this photo, you could see just like tiny, tiny green dots, but this is not the same as duckweed. So duckweed is something that's very common. This is just a floating plant. This is just an actual plant, not bacteria. And if you were to zoom in on this duckweed, you would see an actual like leaf, it looks like a plant. Whereas these very small green dots are kind of amorphous and they're just small and kind of bobbing at the surface or just under the surface of the lake. So duckweed, not a harmful algal bloom. And also not a harmful algal bloom is filamentous algae. So filamentous algae, it kind of develops in these long hair-like strands. It tends to attach itself to the bottom of a stream or lake bed. And you can see kind of as the water moves, you can see that filamentous algae sort of float a little bit in the water column. So if it's filamentous like this, not a harmful algal bloom. And I encourage you to go to that link to look at some additional photos, just to familiarize yourself with all the different ways that harmful algal blooms can present themselves. Now, if you do see one of these conditions, paint streaks, pea soup, green water, we will want to report those suspected HABs to NJDEP. After you submit your StreamWatch online form, then there will be a link. Once you submit that form, a link to click if you need to then report that data directly to DEP. So if you go through that process, if you do report a harmful algal bloom directly to DEP, I just ask that you let me know that you've done so I know that it's done, and so I know that we don't have to take that next step as Watershed staff. So after that, once that suspected harmful algal bloom is reported, there are some other things that are triggered. We could head out with our handheld meter to measure phycocyanin. And phycocyanin levels, which is basically a green pigment, that can be correlated to cyanobacterial cell counts. So this is sort of an analog that we use to measure cyanobacterial cell counts without taking a sample and counting out all of the cells, which can be sort of time consuming. It's an easy way for us to just measure that quickly. And if we're seeing phycocyanin levels pretty high, then we might take grab samples to actually count up the cyanobacterial cell counts to confirm that it's high enough where we may have an actual HAB in our water body. You can also take grab samples to actually quantify toxin levels, so we can measure exactly how much microcystin is in this water body. And all of these public reports then end up on a statewide map. And I will show you that now, actually. Let me just head to my, there we go. Okay. So here we have the current map in New Jersey of all of the publicly reported harmful algal bloom conditions throughout the state. So I'll zoom in on our area here in central New Jersey, and we can see a few different dots here. So up in the northern section here, this is Amwell Lake. And the last time it was actually sampled was on June 29th, and there was a suspected HAB, but the actual results showed that a HAB was not present. That's not to say that it is not present today. And so when you're going out, you definitely want to look at that water body critically and see if there's any changes to that status. Now here, this blue dot, this corresponds to the watch category. So we have all of these different alert levels. If it's green, it's not present. If it's blue, it's watch, meaning we have confirmed cell counts above 20,000, but the toxins are not above a threshold level. Then when we get into orange, that means we do have toxins above that threshold level as well. How do I get out of that? There we go. So here I think this actually just changed. Okay, so here in Rosedale Lake, we have an advisory, which is in that red area where we do have confirmed cell counts. We do have confirmed microcystins. Now down here, we've got Lake Silva and Lake Siva. These are the two lakes on the TCNJ campus. And again, we can see the last sample was on July 12th, and they've determined that there is definitely a harmful algal bloom. So our job is basically just to keep an eye on these things to make sure that they aren't getting worse. And also, if they are improving, we want to make sure that we note that as well, because we could possibly open that water body back up to public recreation. If the levels are bad enough, then the water body is totally shut down to anyone who wants to get in it. Okay, so the next thing, actually, let's go over to our, here we go, our visual assessment form. And let me make sure that I'm sharing that screen. There we go. Okay. So this is the link to our visual assessment form. This is the desktop version. It might show up a little bit differently on your phone. And I encourage you to check this out before tomorrow, just to make sure that you are, familiar with everything and that you're comfortable using it actually in the field. So there's some basic parameters here: your name, your email, the date. We'll set it for August 1st. Our time, 10:45, sure. Now your monitoring sites, all of you will be given a code for your actual monitoring site. For example, a site like CL2, this is Carnegie Lake Site 2. This is an example of what one of those site ID looks like. Now, this next question, is this your usual monitoring location? If you are able to access your water body at the latitude and longitude that I will send you later today, then you can just stick with this. Yes, this is my usual location. If for some reason you've had to access the water body from a different spot, you can click no, and then use this map to zoom in on exactly where you did access your water body. So you can go ahead and zoom in and, pop this blue arrow right on top of where you actually did conduct your measurement. As we go down, we can move on to weather conditions. Today it's partly cloudy. You can select multiple options. If the weather is changing quite a bit, rainfall is pretty important when it comes to E. coli. After a heavy rain, we tend to see those E. coli values jump up significantly, which is why we're asking about rainfall totals. So it might be different, across our watershed, across our region. But if it has rained at the site that you're monitoring in the last 24 hours, you'd want to say so. And then within the past 48 hours as well. If you're not sure if it has rained within that period of time, there's a link here to the Weather Underground weather history page. And you can use basically the same as the map function, kind of like find my location, and then click for yesterday's weather, and it can show if it rained yesterday, or you can just type in a zip code to find local rainfall totals where your monitoring sites are. The next couple questions, pretty basic, just about the water conditions themselves. Water color, if it's clear, if it's light brown, if it's muddy, dark brown, if it's light green, or if it's bright green. We want to know that. Also, the water surface, this tells us how the wind is basically interacting with the water surface. And if these cyanobacteria are being pushed basically to the edge of water bodies, or kind of what's happening there. We want to see if it's calm, if there's just tiny little ripples, if the wind is kind of pushing it, if it's choppy, or if there's white caps, which means that the wind is really going and we can see actually white foam coming from these waves as they break in the lake. So next here for sample collection, hopefully the answer to both of these questions will be yes. Did you collect a sterile sample for bacteria analysis? And did you collect a sample for nutrient analysis? You have different bottles that you'll use for either one of these samples, and I will show you that in just a moment. For algal bloom presence, we are looking at algae kind of on the lake-wide scale. So it could be that most of that water body is affected, or it could be that half of the water body is affected. It could be that algae is scarce, but you do see some kind of like pockets of algae throughout the lake. Or it could be localized, and this tends to be sort of at the edge of the lake where that wind has pushed the harmful algal bloom, that kind of green water to the edge of the lake. You might call that a localized bloom. Now, there are descriptions down here of all of the different types of algae that we might see. But if you do click on localized blooms, half of water body affected, most of water body affected, then these additional questions will pop up to ask you to talk more about what that algae looks like. So what is the algae on the surface of the water? Does it look like green paint? Are they streaky? Is it large globs, bubbly scums, or other? And you can kind of write in here what you mean by other. Then benthic algae, this is algae that's on the bottom of the lake. So surface algae is right there on the top. Benthic algae is kind of covering the rocks or sand or mud at the bottom of the lake. And so it may be that you have algae on the surface, maybe it's green paint, but on the bottom of the lake, you don't really see anything, so that could be none. Or it could be that you have green paint and green covered rocks. So it could be kind of any combination here. And we just ask that you try to report it as best as you can. If you do suspect a HAB, you would click yes here. When you submit this form, I set it up to automatically receive an email so I can see if you have, right in the subject line, if you have said, yes, I suspect a HAB, so that we're able to react to it relatively quickly. Then down below here, we have photos. So you can submit photos directly from the field. One, that's just an overall picture of the water body, kind of like looking back, getting as much of it into the shot as you can. If you do have an algal bloom, this second option is where you can kind of get close up to take a picture of the algal bloom. This is especially helpful, like for other volunteers, just people in the general kind of community science world. Telling duckweed apart from harmful algal blooms is like a really big, helpful thing that we can do before sending out DEP staff to take samples of everything. If it's just duckweed, they don't really need to go out. So this close-up photo really helps us to determine one way or another if it is duckweed or if it is something that needs further investigation. And then here we've got an additional view. This is just an optional additional photo if you have something else that you need to share. So then you would just click that submit button. When you're finished, you can do this directly from the field. At some of the sites, the internet access is sort of slow, or the cell service is not so great. So for some of these sites, and you'll see it, you'll kind of figure it out as you go, you might try to submit this on site, and it might come up with that little circle spinning, and it might be spinning and spinning and spinning for a few minutes. If that happens, go ahead and leave the site, leave this page up, and then basically you'll want to go back off-site, try submitting it again, and hopefully it will work once you have better cell reception. All right. Any questions on that online form? It's pretty self-explanatory, I think. Okay. So now we will get into the actual bacteria sampling kit, the materials that you have in your cooler. So your cooler is this blue little cooler. There's kind of, I think there's 6 of them in the cabinet for people to pick up. Inside your cooler, you will have bottleware. You will have a bag of gloves. You will have different bottles that you can use for nutrient sampling and a thermometer. You'll also have your hard copy chain of custody data sheet, as well as a laminated half sheet that kind of gives you the instructions for how to actually collect your samples in the field, just to kind of jog your memory. Now for the nutrient bottles, for any of these bottles, you'll want to label the bottles with your site name and date before you leave the house, just to give the permanent marker a chance to kind of set in. It's not so great that if you collect a sample and it's wet and you try to label it after the fact, that can get pretty tough. And we want to make sure that we're not messing up and kind of confusing one water body's bottles for another. We want to make sure we're actually measuring the right data for the right spot. So we want to make sure that we're labeling before we leave the house. And also for our nutrient bottles, it is especially better if you've got one of these green tube-like bottles to label on the side of the bottle, not on the cap. But if you have one of these clear, kind of shorter, stout bottles for nutrients, you'll want to label it on the cap. But super duper important that you follow this one way or another. It just helps us when we go to clean those bottles in between weeks to then return them back to you and make sure that they're clean with no labels from prior weeks, so that you can go ahead and label it for your own sites. These sample bottles for bacteria These are sterile bottles, so they might come in one of two different ways. On the left here, we have kind of a shrink-wrapped bottle. That helps us to know that it's coming directly from our supplier. It has been shut, it has been sterilized, and no one has opened it in the meantime. So before you go out and actually collect your sample, you just want to tear off that shrink wrap, that plastic shrink wrap, to collect your sample. On the right here, we also have bottles that may have this sticker on them, and the sticker will be attached here from the cap to the actual bottle. So again, we know it hasn't really been tampered with. And for this, you can feel free to label the bottle directly on the sticker. You don't need to use these particular lines, like you don't need to put in collector and if there was chlorine in your sample, that's not really applicable. You really only need to put your site code and the date. So I just need to know where it was collected from and when it was collected. And that's all the information that we will need. For your bacteria data sheet, your chain of custody sheet, this is what that sheet looks like at the top here. We've got some basic information, the date, your name, sampler name. This is a little bit repetitive, but we're asking again here if there was rain in the last day or 2 days and weather conditions. And this data sheet can be used for all of the sites that you visit, only one data sheet per day for multiple sites, not one data sheet per site. So to fill this out, you're going to enter in your site name. We're using our CL2 as our example again. Your water temperature, your thermometer is calibrated, so it has lines at the nearest 0.0 and the nearest 0.5. So when you record your temperature, you want to make sure that you are recording 27 or whatever the number is, 0.0 or 0.5. Under the samples collected, you're going to put an X under the different samples that you have actually collected. In our case, this will be bacteria and nutrients. Now for the bacteria blank and duplicate, I will reach out to you ahead of time to let you know if I do need you to collect one of these different samples, and I'll provide instructions in that email. Basically, what a bacteria blank is you will fill up one of your bacteria bottles with just regular old water, plain tap water or distilled water. And we will run that at the lab. And hopefully what we'll see is that you're using correct sterile technique, and we'll see 0 bacteria in that bottle. So this is kind of a measure of how well you're collecting your samples. A bacteria duplicate is when I would ask you to, after you collect one sample from your water body with your sterile bottle, you just collect a second bottle. And so we would run both of these bottles, and hopefully what we would see is those results are very close to one another. And this helps to validate our testing method. So again, no need to worry about these blanks or duplicates unless I reach out to you ahead of time to let you know that you should collect them. Now, the time of collection is important to record because, as I mentioned, there is that hold time. We want to make sure that we run the samples at the lab within 8 hours of collection. So your time of collection, just the first time that you stick your first bottle in the water, you can just record that here. And any comments if you feel like I need to know anything else about what's going on in the field. And so, yep, as I mentioned, you would just put all of your sites on this same data sheet, and that's that. Okay, so now let's talk about how we actually collect our bacteria samples. Now, the first thing that you'll do, I don't have any show and tell materials here, but I'll try to explain it. The first thing that you'll do is you will put a glove on the hand that will remove the cap. So I'll just use my water bottle for representation. You've got your hand here. This is gloved. The gloved hand is going to remove your cap. And your gloved hand is going to hold this cap upright so that we're not touching the inside of the cap. We want to make sure that cap is just remaining open, that we're not sticking our finger in it or anything. Now, with our other hand, we have our bottle, and we're going to put that bottle about 6 inches below the surface of the water. We want to avoid trying to get any vegetation or algae into our sample. We just want water. And we want to fill it above the 100 milliliter mark, but not all the way, just making sure that we fill it above the 100 milliliter mark. So you'll see that there is this line up here, almost to the top of the shoulders of the bottle. This line will be your 100 milliliter mark. So you want to make sure that it is above that mark, maybe up to the shoulders of the bottle with a little bit of airspace at the top, which will allow me to shake it up, really distribute that sample before we then go on to subsample. Then you want to recap the bottle and make sure that it's labeled with your site name and date. You've got your gloved hand over here. You have a non-gloved hand here holding the actual bottle. You've dipped that under the water. Then you take your gloved hand and you just gently put the cap back on like that. I call this a one-handed aseptic technique because sometimes science goes through a lot of stuff and there's a lot of waste that's involved in this. And so we can really only need to glove the hand that is removing the cap, and we don't need a glove for the other hand, right? We just want to make sure that we're not contaminating the top of this bottle. If you are in conditions where you see harmful algal bloom at your water body, please feel free, obviously, to use gloves on both of your hands. That's totally fine. And then once you are finished, you've capped your bottle, you've made sure that everything is labeled with your site name and date. You're going to put it into your cooler surrounded by ice. So this is why I've provided a blue cooler. You're going to BYO ice, fill it up about halfway, and make sure you nestle those bottles pretty deep into that water. Our samples need to basically come down from the ambient temperature, which is like around 25 to 28 degrees Celsius. We want to bring it down to below 10 degrees Celsius, between 4 degrees and 10 degrees Celsius. So that's like a real nice refrigerated temperature. We want to make sure it stays pretty cool. So for that, we want to make sure that we're putting enough ice into our cooler and not just using something like an ice pack. We want to make sure that we're really nestling these guys into a cool temperature. Now for our nutrient sample collection, this one is much less strict, I guess, with the sampling procedures. For this, we're reusing our nutrient sample bottles from week to week. So you have 3 bottles in your sampling kit now. You can use all 3 of those for this week. And when you come to the Watershed Center to drop these samples off, there are more bottles for you to pick up for the following week. So you drop off your bacteria and nutrient bottles and pick up another set of 3 nutrient bottles for the next week. So because we're reusing this and we're just kind of cleaning in between, we want to make sure that we rinse these bottles in the stream or lake water 3 times before we actually fill it up. So you can uncap it. You can keep your gloves on from your bacteria sampling. No gloves are really required for this type of sample collection though. And same as with the bacterial bottle though, you're going to submerge it about 6 inches below the surface of the water, avoiding any vegetation or algae, and fill more than halfway. We don't need a whole lot of volume for this actual test. So a little more than halfway is totally fine. Then you would recap it. Just make sure again that everything is labeled correctly with your site name and date. And then drop it in your cooler. Make sure that it is kept on ice and refrigerated for its trip to the Watershed Center. So this is the bottom of your bacteria data sheet, the chain of custody section. The top section is basically you saying, here are the places where I collected samples, and these are the bottles that I've collected. I collected one for bacteria and one for nutrients at each of these sites. Now the bottom of this data sheet is where you would basically say, I have these samples and now I'm going to relinquish them to you, where you're going to have to run your tests on them. And so you are going to sign in this, basically this blue highlighted section. This is where you'll need to fill this section out. You sign saying that you are relinquishing your sample. You record the date that you are relinquishing your sample and the time at drop-off. So not the time that you collected your samples, that's recorded up top. This is the time when you actually are at that bacteria cabinet, dropping everything in the cooler. Now, you also want to record your sample bottle temperature at drop-off. Now, we have sterile bottles, so we are not going to do this by taking off the cap and sticking the thermometer in the bottle. No. We have a special way to measure the bottle temperature, and I will show you that in just a moment. So this is all that you need to fill out. When you get to the bacteria cabinet, you put your bottles into a cooler of ice that is provided. And then when I come out to retrieve sample bottles every so often, then I will sign here saying that I have received them, the date and the time that I have retrieved them from the cooler outside. So if you've already picked up your bacteria sampling kit, then you already know where the bacteria cabinet is located. But it is located outside of the side or delivery entrance to the Watershed Center building. You want to make sure, again, triple check that all of your sample bottles are labeled and that your data sheet is complete. You're going to fill out your chain of custody section on the data sheet. You're going to use the laser thermometer to record the sample bottle temperatures on your data sheet to make sure that you've kept them at a nice, cool, iced, refrigerated temperature on the trip. Then you're going to place, after you've filled out your chain of custody, there's a folder inside the cabinet for you to leave your completed data sheets. There will be a cooler of ice on the ground. You can pop all of your samples right in there and then take your own cooler back with you for the following week. But before you go, make sure that you pick up nutrient sample bottles for the next week. And if you need any other supplies, extra gloves, extra data sheets, extra bacteria sampling bottles, that is also located in that bacteria cabinet, so you can pick those up as you need to. So here's a look at the inside of that bacteria cabinet. These are the 6 coolers that were out for you new folks to pick up. But those will be gone when you actually come in to drop off your samples. So you'll see here on the right-hand side, this is the blue folder to leave your data sheet. Down on this bottom shelf, these are the extra supplies. We've got extra bacteria sample bottles, data sheets, gloves, instructions. And then here we have this tray that has the cleaned nutrient bottles for you to pick up for the following week. So here's a closer look. What I do is I clean these in alcohol, and then I'm going to put them in this tray to kind of dry. So I don't want to cap them right away after I clean them. So when you pick up a bottle, make sure that you grab a cap as well. So you have a cap and a bottle. Some of these already are capped, but you'll just want to grab 3 bottles. Make sure that each one has a cap. Okay. Now here is the laser thermometer. I recorded a little video to show you how to use it. So it has that little trigger, right? That gray trigger. And I will, oh no, it's showing up sideways. Okay, so you're going to pull that trigger. There's a laser that you aim at the side of the bottle. So you would aim it basically right at the side of the bottle here without opening the bottle. And when you release that trigger, you're going to see this hold sign show up. And so once you release that trigger, that number, whatever it last measured, is going to remain on this screen. So in this case, the side of the store was 33.0 degrees Celsius. Hopefully your bacteria samples are a little cooler than that, below 10 degrees Celsius again. So you just aim it at the side, release, and record the temperature of the side of the bottle on your chain of custody form. Now for our water quality standards, this is kind of what we're aiming for with the results. Once you drop off those samples, we run it in the lab for E. coli, for total coliform, as well as nutrients. But for E. coli, we don't want to see any sample above 235 colonies per 100 milliliters of water. But when we're looking at all 5 of these samples within a 30-day period, we want that geometric mean to be below 126 colonies of E. coli per 100 milliliters of water. So this is our goal. If we stay below this, we're looking pretty good. In most cases so far, we have come much, much higher than these standards. So we're really seeing we have issues with E. coli across the watershed. And you're helping us to quantify that. And hopefully that will lead to some changes in the future. All right, so just to sum up here, your routine, right? Before you leave the house, it might be helpful to check that link, weatherunderground.com/history, to check your local rainfall totals, just to see before you leave the house if it has rained in the last 24 to 48 hours. And this will just help you in the field to answer those questions. Has it rained? Yes, no, yes, no. You want to make sure that you label your bottles before you leave the house. Use a permanent marker, write the site name and the date on all of your bottles. 1 bacteria bottle for each site and 1 nutrient bottle for each site. You also want to fill up your cooler with ice before you leave the house. About half full, maybe a little bit more than half full would be great. You are going to head out to all 3 of your monitoring sites, hit each spot, do your visual assessment with the phone app, complete the hard copy chain of custody data sheet, measure the temperature of the water with your purple thermometer, and collect your water samples at each site. Then drop all of that stuff off to the Watershed Center by noon. And so it really kind of depends on where you are located in relation to the Watershed Center. But I would say it will probably take about 1 to 2 hours every Sunday